Well, hello everybody. In this video, I am going to show you how to use SPSS to conduct chi-square analysis. Now, you remember from your readings that chi-square, there are actually two versions of chi-square analysis. There's the goodness of fit version and the test of independence version. And I'm going to show you both methods and a couple of ways to get what you need done accomplished. So on the screen here, I have data set for the two examples that I used in lecture. The goodness of fit example was different styles of commercials and people's intent to purchase a product. If you remember, the commercials could be either informative, a cute story, or a sexy commercial. And then in the test of independence, we looked at the association between personality type, introvert and extrovert, and pet choice, either a cat lover, a dog lover, or a bird lover. So I'm going to demonstrate both of those in a couple of different ways. I'm going to start off with the goodness of fit test, and the first method I'm going to show you is the raw data method. And this first column here is the only column you need if you have every individual's response. Okay, so I defined a variable and called it commercial, and then people were entered as either choosing the informative, the story, or the hot and steamy version. To calculate your chi-square analysis, we simply go to the Analyze menu, scroll all the way down to the non-parametric test option, scroll down to Legacy Dialogues, and then chi-square. Okay, a little tough to get there, but straightforward enough. Then we move the commercial, because that's the only column we need. I could have just a data set that only has one variable in it, one row of data, that's all, or one column of data, and that's all we need. The rest are for other analyses. So I'm going to move the commercial variable into the test variable list, and we're going to keep everything else the same. The expected range is going to be gotten from our data, and the expected values are all equal. And this is the way that we talked about it in the lecture. So that if our null hypothesis said that there is no preference to commercial type, then that means that the expected values should be equal in all three categories. And that's the way that we're doing this analysis. So that's all I have to do is move that variable over the test variable list, leave all of the defaults the same, and click OK. Move this over. And here we have our tables. The first table is the table with the observed and the expected frequencies for the three groups. And below that is the value of chi-square, the degrees of freedom, and lastly the p-value, when we see that p is less than 0.001, meaning we have a very compelling argument that the null hypothesis is not a good explanation for this pattern of data. All right, so that's it. Really straightforward, really easy. Now let's go back to our data, and let's suppose that you don't have the raw data. You just have a table with summary information, like there were 8 people who chose informative, 12 people who chose story, and 40 people who chose the hot and steamy commercial as what influenced them to buy the product. Well, if I don't have all of the raw data, what do? Couple of steps, not much more difficult, but we have to do one step first, which is to weight the cases by how things are distributed. All right, what does that mean? I go to the Data menu instead of Analyze, Data, go all the way to the bottom to Weight Cases. And when I select that, I simply change the button from Do Not Weight to Weight Cases, and we want to weight them by the count. So in this version, I have 2 columns, one with the type of commercial and another one with the number of people who chose that commercial. I'm going to move the number, the frequency variable over to the weight cases side. Click OK. All right, now our data are going to be weighted. So I can go back to Analyze, Non-Parametric, Legacy Dialogues, and finally chi-square, just like we did before. Let me reset this. This time, since, if you remember from our data, the com type and count were the 2 columns. We're weighting by count. So I'm going to move the com type variable over to the test variable list. Once again, we keep everything the same, and I click OK. And now you see, once again, the observed and expected values and the chi-square, and notice the chi-square values for those two analyses are identical. So the weighting cases approach you can use if you just have a table and no raw data. Works just as well. Just remember to go to data and weight the cases by the frequency column first, then do your chi-square on the com type. Now, that's if our groups have equal expected values. What happens if you don't expect equal numbers? What happens if instead you have to match the expected frequencies by some previous research? All right, let's say in this example that 50%, back in the 1950s, there was research in the 1950s on commercials that 50% of people preferred the informative commercial, 30% preferred the story commercial, and 20% preferred the sexy commercial, right? 1950 is a different time than today. So do those rates still hold up? Well, we can analyze the data just the same. I'm going to keep everything the same as we did in the weighted cases, so I don't have to change anything. But this time when I go to non-parametric, legacy, and chi-square, everything is set up the same here. I can just go to the expected values and change it from all categories equal to values. Now the values that I want to enter here need to be in the same order as your categories in that you're analyzing. And our categories are group 1 was in the informative commercial, group 2 was the story commercial, group 3 was the hot and steamy commercial. So the informative commercial, 50% of the values should be choose informative, right? That's what we're comparing it to. Well, 50% of the 60 subjects would be 30. So I'm going to add that in. Now, I said 30% chose the story commercial in the 1950s. Well, 30% of 60 times 0.3 is 18. So I'm going to add that in. And lastly, 20% of the people in the 1950s chose the sexy commercial type. Well, 20% of 60, 0.2 times 60 is 12. So I'm going to enter 12. Click add. There's my three preferences or expected values, because I'm expecting, the null hypothesis says that our observed counts should be pretty similar to the 1950s. That's the null hypothesis. So I'm all set up. I click OK. And notice, oops, here we have the informative with 30, the story with 18, the hot and steamy with 12. And when we conduct that analysis, that chi-square, we get a huge chi-square of 83.467. Obviously, that's a very low p-value because the data are pretty much in the opposite direction of what we expected from the 1950s. So that's how you would use a weighted, not weighted, but this is how you use unequal expected values. Just remember to enter them in the order consistent with the order in your observed cases. And that takes care of the goodness of fit test. So let's go back here. I'm going to unweight the data, so I need to reset this, and I want to show you the test of independence now. The test of independence uses a different dialog box, but once again we have our two columns, one column with the introverts and extroverts, one column with the pet choice. And you see for this introvert chose cats, and this introvert chose dogs, this introvert chose birds, right? This is a big long file of raw data, 2 scores from each person. Now we go to the Analyze menu, but this time we're going to stop at Descriptive Statistics and move down to Crosstabs. Crosstabs is an unusual name, I get it, but choose Crosstabs. And now we see a menu with all of our variables on the left and rows and columns. And we can just move the 2 variables of interest into the rows and columns. I'm going to move the personality type into the rows and the pet choice into the columns. That's going to match the table that I had in my lecture. Now I click on the statistics button, and I want to make sure that we get a chi-square analysis. Click continue. The cells, when I click the cells button, it's all automatically going to give me the observed frequencies, but I'm going to tell it to also give me the expected frequencies so that it's all there and I can see it all. I can also get percentages, a whole bunch of things, but I like observed and expected. Click continue. And lastly, I want clustered bar charts. I want to visualize my data. So I click that box, and that's my setup for a test of independence. Now when I click OK, there we go, it took a second. Here we get our summary. We can ignore the case processing summary. Here is the observed and expected values for our groups. We have introvert cat lovers, introvert dog lovers, introvert bird lovers, 55, 22, and 12. And below that are the expected counts. And then there's the expected counts, and then there's the expected counts total. So these data match what's in the lecture. Below that is the chi-square analysis. Once again, as I told you in lecture, we're only paying attention to the top row. Notice the chi-square value for this is the same that we calculated in lecture, 43.013, and the probability of getting that is less than 0.001. We can ignore the likelihood ratio and the linear by linear association approach. Okay, and then here is that bar chart, the same bar chart that I showed in lecture. Because I checked that box, you can get a visual of your data. But that's the test of independence. By telling it to give me both the observed and the expected values in here, I can see the pattern for interpreting my my chi-square analysis and see that way more observed than expected cat lovers were introverts, and way more dog lovers were extroverts than expected. So there you have it. There are the two different ways of calculating a chi-square analysis, including using raw data, using summary data, and using both equal and different values. I hope that was helpful. Let me know if you have any questions.